First of all, I'd like to say thank you everyone for coming out today. And my name is Michael Dixon, and I would like to discuss with you regarding my green sand castings of converting an injection molded pattern into a gravity-fed green sand casting. So first of all, this project, you need a little background of what castings are. So a metal casting is taking a material, in this case aluminum, melting it down to a liquid state and pouring it into a cavity which you get your parts out of. In my case, at the lower left here, is the original pattern I purchased from Citadel Miniatures, who produce these commercially. That is a pattern which is injection molded, hot liquid plastic resin injected into a mold to fill out all the parts. So what my goal is to convert that into a green sand casting, as I said. And in order to do that, I determined that I would need to primarily expand the gating on the system, which are the horizontal and vertical lines in between each of the parts. And in the end, the parts will be cut out and assembled into models such as these here, which are used for a hobby mine, which are based very heavily upon aesthetics and detail when you go to different games and tournaments. And so to produce a green sand mold, in the simplest sense, you have your pattern, in this case the manufactured one, and then in the center picture of the testing, there's a sample of a flask being poured. And in essence, you have your container and you press the top half of the design into one side, and on the other side, you press the bottom half. And then once you remove the pattern, you have a cavity that's left, and you pour material into it, and that allows you to fill in your parts, hopefully. And so the first part of it was manufacturing and modifying the pattern itself. In order to do this, my testing and analysis essentially was done via SolidWorks and SolidCast. I modeled the pattern itself in SolidWorks following the current gating system and rough dimensions of each of the parts. And then I subsequently loaded into SolidCast and did simulations of material flow of aluminum at 14 to 1425 Fahrenheit. Running through there, and I found that I needed to expand the gating on it to about a 0.15 by 0.20 inch dimensions throughout. So if you see the upper left-hand corner there, the lighter gray material is the modified gating that I did, and I used Flexol epoxy, which after applying it and allowing it to dry out a fair amount, I then sanded and removed down to the required dimensions as I went. I ran into some trouble that if I waited past about 36-hour period, it would get fully cured and very brittle. And so as I was sanding it, I tended to chip off pieces of it, and that required me to do some repairs and patches as I went. Though the brittleness was breaking apart due to the different angles I was putting on it. When the castings, that you're only pressing straight down, so there's no trouble of damage. And so my criteria for going through this project is listed here in the center of the slide. I had 5 primary components, all based on a 1 to 10 scale. First being the material flow throughout the project, and that was one of the key points that I was looking at. And that I wanted a minimum of 9 points throughout, and I'll discuss the results of these in a little bit. The usability of the parts, the detail retained, the ease of assembly, and the ease of the gating removal. All I wanted a minimum score of 7 points or greater. These are all very important. The cosmetic, the detail, especially so. As you can see in the upper right-hand picture, I was able to get a good amount of detail out. Some pieces did not turn out as well as I would have liked, but in general, I got very good-looking pieces, and if I were to bring them to a show, they would be judged, I would say, almost comparably with some of the other pieces that are out there that people make at home for their own custom work. Some of the difficulties I encountered was when I would make the mold. If you take a look at the upper right here, the gating system between the parts themselves narrowed the spacing, so the gating became a little wider, and therefore there's less space between the parts and the gating. And so when I removed the pattern from the sand, it had a tendency to take sand with it, which would destroy some of the detail on the parts. And so as I removed it, some of the parts would be damaged. And so if you look at the bottom side of the picture here at the top view, especially around the edges, there's a lot of excess material, which should be considered flashing, flowing between areas you don't want. And so that was very problematic. And so to sort of address that, I was able to focus more on the critical components of the project, which are the ones I scored, instead of some of the more cosmetic ones, which I have replacements of at home. And the pieces marked in red are the cosmetic or non-essentials, and the pieces marked in orange are the essential pieces and the ones that are scored. And so after focusing more on the essentials, I was able to get much more reliable castings out. And there was a little bit of flashing between the pieces, but in the end I was able to machine those off very readily and just simply sand them with the Dremel, and the pieces looked pretty well. Another couple difficulties I ran into was working with the SolidCast software. I wasn't familiar with it at the start of it, and obtaining the software ID code and getting it loaded onto school computers was a bit of a chore. Once I got that figured out, it wasn't too bad to work with. It's actually very useful piece of software if you ever want to do any analysis like this. And my anticipated budget, I initially put at $80, but I blew that out of the water and hit $199.52 of my total expenses. And that is due to not having some of the proper facilities that I needed in my castings. And so I had to go ahead and purchase a large amount of solder, which is a tin, silver, lead composite material. And at the end of last quarter, I had to do this in the last minute because the foundry was unavailable for my initial testing to be sure that I was on the right track with this. And so I purchased this material and then was able to pour it in small quantities, just doing one flask at a time. And by pouring this, it didn't really follow the parameters that I had set up, but it did inform me that my molds were producing good detail. I was able to get material to the corner even if it isn't the right material. And so I knew my premise was true, and I was able to continue on my work. And so here I have an image or a video of one of the sample pours that I did with the solder. Here's just the materials melted and ready to go. All you have to do is bring it over once you have everything made up, pour it into the sprue or the spout, and then once it about fills up and you see it rise to the surface, you know that you have enough material. And in this case, I had melted down just what I needed, and then that's all I have to do for a casting. Then you wait perhaps 15-20 minutes and it's fully solidified and then it's still hot, but then you can take it apart and see how your product turned out. The testing I also did was ranged between about 1400 to 1450 Fahrenheit on the SolidCast modeling that I did. And so the pours I did also ranged from, they hit the lowest of things 1375 and 1430 or 1425 is about the highest that I did in my pours. And each pour, they actually turned out very well and had consistent results of material flow. So in my end analysis, this is the summary of all my results. The more detailed information is available in my report, which will be given to the professors here and they'll have on file. But in general, this is the breakdown of it. So the product detail, I got an overall score of a 6.71, which I consider to be a failure in this. I want a 7 minimum. It was, some of it's a little skewed just simply because some of the parts that didn't turn out were consistently not turning out as well in detail, whereas other parts did turn out very well. For example, the models when assembled into a snake. And so this piece here is the casted form, and this is the original commercially purchased one. The detail on the top of the hood here turned out very consistently in all the parts, but at the neck of the snake, this picture doesn't do very well. There is not very good detail produced on those, and that was where a lot of the lower scores came in when I was rating these. Then additionally, the gating removal, which as I said before is the lines between the patterns, was a chore to remove at the best. It involved about 45 minutes to an hour per pattern that I made, and I made about 6 patterns to remove all the gating, get the pieces set up. And at that point, I gave it a score of 4.57 average after removing every piece, and that was a really low score that overall tanked my results in general. The assembly of the parts went much smoother than I anticipated. The parts themselves, plastic ones adhere very well. The pewter ones that the company produces, rubber models don't adhere very well when you glue them. These ones did surprisingly well. The time I spent with the aluminum pieces gluing them together was about 6 hours of active gluing, where I would hold the pieces, give them balance to set them where I need it, and then only about 13 hours of set dry time to give them on the period to cure. And the other piece that we've done full weekends of gluing where we set 2 pieces, leave them sit for 6 hours, put some more glue, leave them sit, and it's quite a process. The assembly though, that's why I gave it 7.24. The successful parts produced out a 6.66 rating, and that is actually the number that turned out from it. Because, as I said, some of the parts really did not consistently turn out. A few of them, of the consistent ones, had issues. That's mainly, as say, the hoods. They typically turned out very well, but this is just the bottom side of it. But on the other side of these pieces, sometimes the sand would break away and you'd have a block of sand, so you cannot put the 2 pieces back to back and connect them to one another. And then material fill was a smashing success. There was no cast that came out having any issue. So overall, total of 7.04 rating, and that's how it came out. Thank you. Any questions?